Hi guys, I hope you're all good. So today we are going to be looking at this question here. It says that a four-digit code is required to open a combination lock. So the code must be even numbered and may contain the digit, may not contain the digits 0 or 1. And then further say that the digits may not repeat. So let's highlight or underline our conditions here. So the first condition that we have here, it is that it must be even numbered. And then second, it says that may not contain 0 or 1. Right, and then last condition here, it says that digits may not repeat. So, and then we also know that we have to make up what? A four-digit code. Right, so now we have those. So it means that in total, how many digits do we have if you can't use 0 and 1? So let's see. You know that the digits are from 0. You know that the digits are from 0. So it's, you know that they are from 0, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 and then we have 9 here. So meaning that we have 10 digits in total. Right? But then in this instance here, they said that we can't use 0, we can't use 1. So meaning that in total we have how many digits? We have 8 digits in total. Right, so now, and then now, let's take a look at this now. Now, that for a code of a number to an even number, we know that according to this example here, since you can't use 0 and 1, it means that the code to be an even number in this case should either end with what? Should either end with 2, 4, 6, 8. Right? So for a number to be an even number, we know that it must be divisible by 2. And then how do we see that a number is divisible by 2? Sometimes it's either end with 0, 2, 4, 6, and 8. But then in this instance, we can't use 0. So meaning that it can only end with 2, 4, 6, and 8. Right? So now, so let's move on to 10.2.1. It says that how many four-digit combination are there to open the lock? So we have 4 digits. And then remember, we have a restriction that our code must be an even number. So we know, and then we have already covered that for a code to be an even number, it should end with 2, 4, 6, and 8. Right, so we always start with the restriction. So our restriction here is 1, 2, 3, 4. So we have 4 choices to choose from. Right, so if we have 4 choices to choose from, here we can just say that we have 4 choices to choose from. Right, so in this instance, this is the only restriction that we have. So meaning that now we have chosen the last digit. Right, so in how many total digits do we have to choose from? Since digits are not allowed to repeat, we are now only left with 7 digits to choose from. So it means that we can have 7 here, and then we can have 6 here, then we can have 5 here. Right, so that when we calculate for this, or to find the total number of possible 4-digit codes, this can be calculated as 7 times 6 times 5 then times 4 here. So that's what we have. So we know that when we do this, we can just simply open our calculator here and do this using a calculator. So we can just say this is 7 times 6 times 5 times 4, and then you are going to get that our answer is 840. So when you get 840, you are going to say this is 840. Right, so this is 840 possible 4-digit codes. Right, so that's what we have. So it means that if we were to follow these conditions that we have here, we can make up to 840 possible 4-digit codes. So now let's move on to the next question here. So the next question here, which is 10.2.2, it says that we should calculate the probability that you will open the lock at the first attempt if it is given that the code is greater than 5,000. So this is another restriction or another condition. And then it further now says that, and the third digit should be 2, right? And then that's what we have there. So now let's take a look what we have here. We have 1, 2, 3, 4. Then remember, what do we have? Let's take a look at what should happen here visually. We know that the third digit should be 2. And then for a number to be an even number, it should end with 2, 4, 6, and 8, according to these set of numbers. Right. So now, let's take a look at what happens as well. Now, for a code to be greater than 5,000, it should at least start with 5, right? So in this case, we can the code here can start with 5, can start with 6, 7, 8, and 9, right? So it means that these can be 5, 6, 7, 8, and 9. Right, so this is what we have here. So but then let's look at what we have here. Remember, the third digit here must be 2. So if the third digit here must be 2, it means that we can't have another 2 here, because repetition is not allowed, right? So meaning that the only now conditions that we have, it means that this leaves us that we have now this condition here. We have 5 here, we have 6 here, we have 7, 8, and 9, and then these can only be 2. So meaning that here we are only left with 3 options: 4, 6, and 8. All right, so this is what we have here. But then remember, we still have a conflict, right? So how can we get rid of that? Remember, now we still have 6 here, we still have 6 here, we still have 8 here, and then we still have 8 here. Then remember, repetition is not allowed, right? So how can we handle this? So now remember, now we can just treat this as 2 separate conditions, right? So now let's take now if our code was to start with 5, 7, and 9. So let's take, we have 1, 2, 3, 4 codes, right? So we know that we must only have 4 codes, right? So it must be 4 codes. So it must be 1, 2, 3, 4. So now let's say now if we're to start with 5, 7, and 9, then meaning that this position now can be filled with, now it can be filled with 4, 6, and 8, and then these can be only be filled with 2. And then looking at this now, we no longer have any conflict, right? So now, so that leaves us that to choose this restriction, or for a number to be a restriction, to be an even number, we are only left with what? We are only left with 3 choices to choose from. So this is 3, and then here we are only left with 1 choice, and then here we are only left with 3 choices. And then remember, because we have 8 numbers in total, we have already chosen 3 numbers already. So that leaves us with a choice of how many numbers? A choice of 5. So remember, 8 minus 3, because we have chosen 3 already, so that leaves us with 5 option of 5 choices. So this means that this can be done in 3 times 5 times 1 times 3 ways, right? So, and then remember, it is not only that our code can start with 5, 7, and 9. We have another condition that our code as well can also start with. So let's say 1, 2, 3, 4. Our code as well can also start with 6 and 8. Then now, as well, let's take a look at what can happen. At the same time, these can also be 4, 6, and 8. Right? So we know that if our code now can start with 6 or 8, what can happen? It means that we have two choices to choose from. It's either it can start with 6 or 8. But then now, what happens now? What happens now if it starts with 8? It means that we can't have a 6, right? Or what happens now if it starts with what? With 8. It means now we can't have an 8 here. So that always leaves us with how many choices? It always leaves us with two choices, because if we start with an 8, we can only have 4 and 6. But then now, if we start with 6, we can only have what? We can only have 4 and 8, right? So that's what we have. So it means that we are always left with two choices if we were to start with either 6 or 8. So now, to choose the third digit, remember we only have one choice here. We can just say this is 1. And then now, to choose the second digit here, how many choices do we have? We still have 5 choices to choose from. So we have to write 5 here. Then now, how do we handle this? We know that this condition can happen in 2 times 5 times 1 and times 2 here. So meaning that what can we do here? We know that to find the total arrangements here, that this can happen, or to find the total possible 4-digit codes here, we can just say that this is 3 times 5 times 1 times 3 plus what? Plus 2 times 5 times 1 times 2. So all of these, you can just put all of this into the calculator and see what we get. So now we have that this is going to be 3 times 5 times 1 times 3. Right? So this is what we have here. And then we get this, and then we know that we are going to say plus 2 times 5 plus times what? Times 1 times 2. And we get that this is equals to 65. So now we write 65. So we write 65 here. So 65. So this means that this can be done in 65 different ways, right? Or we can have 65 different 4-digit codes, right? So if we were to follow all the conditions. Now remember, because we have to calculate for probability, we have to calculate the probability. Then now, what's our sample space? Remember that our sample space here in this case can be the answer, or the number that we have calculated in 10.1 and 10.2.1. Then what did we find here? Remember, we got that this is 840. So we know that to find the probability here, it's going to be 65 over 840, right? So that now our probability, if you want to simplify this, you can just open your calculator. So this is going to be 65 divided by 800. Oh, this is supposed to be 840. So divided by 840 in this case. So that our answer here is 18 over 168. So 18 over 168. This can also be translated to 0,077, but then we can just leave it as 65 over 840.